P6, factoring. When we factor, we first want to look at factoring out greatest common factors. If we look at example 1a here, we have 3x squared minus 6x. We're going to factor out the greatest common factor, which is 3x. So this is just turning into 3x times x minus 2. For b, we have 8x to the 4th power y to the 2nd power plus 6x cubed y cubed minus 2xy to the 4th power. So our greatest common factor here is 2xy squared. So this is going to turn into 2xy squared times 4x cubed plus 3x squared y minus y cubed, or sorry, y squared. For c, we have negative 15y to the 4th power plus 5y cubed minus 10y squared. So our greatest common factor there is a negative 5y squared. We always want that first term to be positive. So this is going to turn into negative 5y squared times 3y to the 2nd power minus y plus 2. For our example 2, we're just factoring out a greatest common factor here. So this, they both have the x minus 3. So this x minus 3 is going to be written down. And then you're going to have another set of parentheses, which has the 2x plus 4 and that minus 5. Oops. So from here, we're just going to combine like terms in that second set of parentheses. And this turns into x minus 3 times 2x minus 1. When we factor trinomials, if our a is 1, so that coefficient of x squared is 1, we're going to find the factors of that c term that add up to be b. So the negative 48, to get the negative 2, we have 6 minus 8 is negative 2, and 6 times negative 8 is negative 48. So this turns into x plus 6 times x minus 8. For 2, we have y squared minus y minus 30. So that negative 30, you have 5 and negative 6, which is going to multiply to give you negative 30 and add to give you negative 1. So this just factors out to be y plus 5 times y minus 6. For 3, you have x squared plus 17x plus 30. Your factors of 30 that add up to be 17 are 2 and 15. So this factors out to be x plus 2 times x plus 15. For 4, we have y squared plus 6y minus 27. So the negative 27 has factors of what and what that add up to be the 6, the positive 6. It's going to be a negative 3 and a positive 9. So this factors out to be y minus 3 times y plus 9. For 5, we have x squared minus 23x minus 50. So your factors of negative 50 that add up to be a negative 25 are a positive 2 and a negative 25. So this factors out to be x plus 2 times x minus 23. Sorry, minus 25, not 23. When your a is something other than 1, so it's bigger than 1, we're going to multiply that a and that c term, find the factors of that in order to give us that b term, replace the b term with those two factors and the appropriate variable, and then factor by grouping. So with this one, number 1, we have 3x squared minus 2x minus 5. The 3 times the negative 5 is negative 15. We're going to find the factors of negative 15 that add up to be negative 2. So this is going to be 3 and negative 5. So this factors out to be 3x squared plus 3x minus 5x minus 5. And if we factor by grouping, we're going to group the first two terms and the last two terms, factor out their greatest common factor of each. From the first set, it's going to be the 3x. From the last, it's going to be a negative 5. So this turns into 3x times x plus 1 minus 5 times x plus 1. Since those two parentheses are the same, we're going to have one set that is the x plus 1, and then we'll make another with the 3x minus 5. So our factored out trinomial ends up being x plus 1 times 3x minus 5. For example 2, we're given 2y squared plus 3y minus 9. So 2 times negative 9 is negative 18. The factors of negative 18 that add up to be a positive 3 are going to be 3 and 6. So the 3 is going to be negative, the 6 will be positive. So this is 2y squared minus 3y plus 6y minus 9. We factor by grouping. The first set of parentheses, factor out a y. Second, factor out a 3. So this is y times 2y minus 3 plus 3 times 2y minus 3. Our two parentheses are the same, so rewrite it once and make another set with the y plus 3. So 2y minus 3 times y plus 3 is our answer. For 3, we're multiplying the 5 and the 12. 5 times 12 is 60. The factors of 60 that add up to be the 19. Your 60 is 1 and 60, 2 and 30, 3 and 20, 4 and 12. No, 4 and 15. So 4 and 15 are going to give you that 19. So this is going to factor out, or expand to 5x squared plus 4x plus 15x plus 12. Group the first two, group the last two, factor out the greatest common factor. With the first set of parentheses, it's just an x. With the second, it's a 3. So this turns into x times 5x plus 4 plus 3 times 5x plus 4. Two parentheses are the same. Rewrite one and form another with the x plus 3. For number 4, we have 2y squared plus 11y plus 5. So that 2 times 5 gives us 10. Your factors of 10 that add up to be 11 are 1 and 10. So this turns into 2y squared plus y plus 10y plus 5. So group the first two and the last two. Factor out the greatest common factor of both. This is going to leave us with y times 2y plus 1 plus 5 times 2y plus 1. Two parentheses are the same, so this turns into 2y plus 1 times y plus 5. For 5, we have 2x squared plus 5x plus 2. So 2 times 2 is 4. Factors of 4 that add up to be 5 are 1 and 4. So this is 2x squared plus x plus 4x plus 2. Factor by grouping. Pull out your greatest common factor of both. So this turns into x times 2x plus 1 plus 2 times 2x plus 1. Parentheses are the same. 2x plus 1 times x plus 2. If we look at example 5a, we have x squared minus 2x minus 3. Your factors of that negative 3 are 1 and 3. If the 3 is negative and the 1 is positive, that's going to give us our negative 2. So this factors out to be x plus 1 times x minus 3. Example B is a little bit different. You have 5a plus 1 squared minus 2 times 5a plus 1 minus 3. This 5a plus 1 squared is the same thing as 5a plus 1 times 5a plus 1. We can FOIL the front and distribute the negative 2 and combine like terms with the back. If we did that, we would have, well, yes, we would have 25a squared plus 2 times 5a times 1, which is 10a plus 1 minus 10a minus 2 minus 3. So I just FOILed the first two, distributed the negative 2 into the last set of parentheses. From here I can combine my like terms. My 10a and my negative 10a will cancel. Negative 2 minus 3 gives us negative 5, plus 1 is negative 4. So that's 25a squared minus 4. We can see that these two are perfect squares and they're separated by a negative. So this turns into 5a minus 2 times 5a plus 2. And it's just a difference of squares. With special factoring formulas, for a, we have 4x squared minus 25, the same exact thing that we just did. So this is going to be a 2x minus 5, 2x plus 5. Again, it's a difference of squares. For b, we have x plus y squared minus z squared, so we're going to do the same thing, difference of squares. So x plus y minus z, and x plus y plus z. So from here we can just get rid of the double parentheses within each other, and this is just x plus y minus z times x plus y plus z. For our next example, we have y squared minus 100. So again, take the square root of both, separated by a negative. That's y plus 10 times y minus 10. For 3, same thing, take the square root of both, separate by a negative. So this is 3x minus 9y times 3x plus 9y. However, they both share a common factor here, so we are going to erase this and do this over and say to ourselves, what is the first step when solving or when factoring expressions? Do they have a common factor? In this case, yes, it's 9. So we're going to factor out a 9 first. That gives us x squared minus 9y squared. Now, we can still take the square root of both terms, and they're separated by a negative. So this is going to be 9 times x minus 3y times x plus 3y. For 4, we have 49y squared minus 1. We're going to take the square root of both sides, separate by a negative. We're good to go. So that's 7y minus 1 times 7y plus 1. For example 8a, we have a perfect square trinomial. So what happens when we do these is that we're going to take the sign of that middle term. We're going to take that and apply it to a 2, so it's going to be positive 2. Then we're going to take the square root of the first term, that's just x, so we'll multiply it by the 2. Take the square root of the last term, that's 3, we'll multiply it by the 2. This gives us the 6x that's in the middle, so that's our b term. If that's the case, this is a perfect square, or yes, a perfect square trinomial, which means keep the middle term, sign, and then put what you multiplied the 2 by around that sign, put parentheses on it, and square it. So this is just x plus 3 squared. Do you have to do it this way? No. You can find the factors of 9 that add up to be your b term, and then factor it that way. When you do that, you'd have x plus 3 times x plus 3, so you just rewrite it as x plus 3 squared. For b, we're going to take the square root of the 4x squared, we're going to take the square root of the y squared, we're going to apply the negative to a 2, and multiply it by the 2x and the y. This gives us negative 4xy, which is that middle term, so we can factor it using a perfect square trinomial. So the square root of that 4x squared was 2x, the square root of that y squared was y. The sign on our middle term is negative, so that's what separates these two. We put parentheses around it, and we square it. When we factor an expression completely, we want to look for a greatest common factor and factor that out first, just like we did with a few of those questions before, the one that we last did. So for a, we have 2x to the 4th power minus 8x squared. We're going to factor out a 2x squared from this, because that's the greatest common factor, and this leaves us with 2x squared times x squared minus 4. This is a difference of squares, so this factors out even further to be 2x squared times x minus 2 times x plus 2. For b, we have x to the 5th, y to the 2nd, minus x, y to the 6th. So we're going to factor out an xy squared. This is going to be xy squared times x to the 4th minus y to the 4th. So then this factors out again to be xy squared times x squared minus y squared times x squared plus y squared. From here, then you can factor out the x squared minus y squared. So then this factors further to be xy squared times x minus y times x plus y times x squared plus y squared. For 1 in this section, you have 2x squared minus 18x plus 40. Factor out the greatest common factor, which is 2. So that's 2 times x squared minus 9x plus 20. Your factors of positive 20 that equal a negative 9 are a negative 4 and a negative 5. So then this factors out further to be 2 times x minus 4 times x minus 5. For 2, we have 2y cubed plus 3y squared minus 5y. We're going to factor out a y. So this is y times 2y squared plus 3y minus 5. You're going to multiply the 2 and the negative 5. That gives us negative 10. Your factors of negative 10 that add up to be a 3 are negative 2 and positive 5. So this is going to be y times 2y squared minus 2y plus 5y minus 5. We're going to factor by grouping. I'm going to pull out a 2y from the first set and a 5 from the second. So this is just y times 2y times y minus 1 plus 5 times y minus 1. From here, we are seeing that our parentheses are the same, so this finalizes to be y times y minus 1 times 2y plus 5. Grouping, I think these two, right, so with A, we're going to factor by grouping, which we've done this entire time almost. Group your first two, group your last two, factor out the greatest common factor from each set of parentheses. We're going to have an x squared and a 4. So this turns into x squared times x plus 1 plus 4 times x plus 1. Parentheses are the same, so we rewrite x plus 1, and then we write another with the x squared plus 4. For b, same thing. Group the first two, group the last two, factor out the greatest common factor from each. We're going to have an x squared and a negative 3. So this is going to be x squared times x minus 2 minus 3 times x minus 2. Parentheses are the same, so x minus 2 times x squared minus 3 is that polynomial factored out. For our last set of examples, we're going to be factored by group factoring. Are they the same? No, they're not. For 1, we have 12x cubed minus 9x squared minus 4x minus 3. So we're going to factor out a 3x squared from the first and a negative 1 from the second set of parentheses. So that's going to give us 3x squared times 4x minus 3 minus 1 times 4x plus 3. So because our two signs are not the same here, this is prime. So whenever you get something that you cannot factor out completely, or you can't factor at all, it's prime. For 2, we have 2x cubed plus 5x squared plus 6x plus 15. We're going to factor out an x squared from the first set and a 3 from the second. So it's going to leave us with x squared times 2x plus 5 plus 3 times 2x plus 5. Our two parentheses are the same, so we're going to have a 2x plus 5 and an x squared plus 3. For 3, we have y cubed minus y squared plus 2y minus 2. We factor out a y squared from the first, factor out a 2 from the second. This is going to leave us with y squared times y minus 1 plus 2 times y minus 1. Your two parentheses are the same, so write down one of them and then make another with the y squared plus 2. So we have y minus 1 times y squared plus 2. For 4, group your first two, group your last two. Pull out a 5y squared from the first set of parentheses and a 3 from the second. We're going to have 5y squared times y minus 2, and that 3 times y minus 2. So this, we're going to rewrite the y minus 2, make another with the 5y squared plus 3, and then we have our answer.